So we've learned that we can change the wavelength of our sound by controlling the length of our strings. And the reason we can do that so well is that we're forcing it to be at a node wherever we sort of fix the string. And when we have a woodwind instrument, that's actually a lot harder, because if I am going to be blowing into this, supposing this is a bad didgeridoo, if I'm going to blow into this, then is this point here going to be a node or an antinode? How's that going to work? And the actual answer is that that's quite a complicated issue, and it depends on technique and skill. So you should get someone to show that to you. The speed of sound can't really be changed. So when we had a guitar string, we could use strings of different tension and different density and so forth, and that would give us different speeds. We don't really have that control over air. The speed of sound in air does depend on things like pressure and so forth, but it's hard to change that dynamically when you're playing an instrument. So really all you can do is try and adjust exactly where you're getting nodes and antinodes by careful mouth placement and so forth. But you can hear very clearly the difference between having open ends and closed ends. So supposing I close that end, so I'm certainly not going to have an antinode at the point where my hand is, and if I make a sound, you get a note. And if I take that hand away and make the same sound, firstly it's louder because I'm getting more airflow, I guess. But you'll note that the frequency is different, it sounds different. And in fact, they're an octave apart. Bom, bom. That octave means that we're having a doubling of the frequency, which means the two situations there where I have the hand over one end or not, somehow I'm getting twice the wavelength in one case. So, what's a good model for what the waves are doing inside that pipe? So I've got two cases of the pipe. I've got a pipe where I have my hand over one end. I've got a pipe where I don't have my hand over one end. So when I've got my hand over one end, then I'm pretty sure that what I'm going to have here is a node. Right? I'm not going to have any airflow there. And so at the other end, I'm only going to have an antinode. And if it's an antinode, then the fundamental standing wave is going to look like that, which would be a quarter of a wavelength. The other possibility is that I might have it being a node at the other end, in which case what we've got is a half a wavelength across the length of that pipe, thereabouts. Okay, so what I do know is that when I take my hand away, I get a different sound. So I'm pretty sure that what we go to is something with an antinode at the other end. So the two possibilities are antinode to antinode, because I haven't really changed what's happening at the other end, or antinode to node. So I'm fairly comfortable with my guess about what's happening at this end. I'm fairly comfortable that if I got my hand over it, I should have a node there. That's just like holding a guitar string still, right? And if I'm changing something, and I am definitely changing something because I can hear a change, then it must be going from closed to open at that point. So I'm happy with this side. So the real question is, what's happening over on this side? I'm not sure. So either it's open, and so we're going from that case to this case, or it's closed, in which case we're going from this case to this case. And so the real question is, which of these is happening? So in this first case, where we tap the hand and we get an antinode, then what's happening is we're going from a quarter of the wavelength fitting in our tube to half the wavelength fitting in our tube. And that means that the wavelength has halved. And if we've halved the wavelength, so if that goes down by a factor of 2, then the frequency has to go up by a factor of 2. So in this case, the frequency would double. And the other case, where the hand that we're tapping is where we got a node, then in that case it's also changing by a factor of 2, but you'll note it's going the other way. So in this case, we're going from there, where we've got half the wavelength fitting in the tube, to there, only a quarter of the wavelength is fitting the tube. So in that case, the wavelength is doubling. And if the wavelength is doubling, then the frequency is halving. So in both cases, we've got to change by an octave because the frequency is either doubling or halving. But in one case, when we take the hand away, the frequency is going up. In the other case, when we take the hand away, the frequency is going down. So let's check to see which one it is. So that's a node. So is this going to be an antinode or a node? So if I go like... it definitely went up as I took the hand away. And what that means from our analysis, it means that the hand that I was banging, that place must have been an antinode. In other words, I was getting large movements of air exactly where I was hitting it, which makes sense. And indeed, this kind of antinode tends to happen at the open end, and a node tends to happen at the closed end. So if you have a pipe with two closed ends, you'll tend to get this kind of thing. And if you have a pipe with two open ends, you tend to get that kind of thing. And finally, of course, all of these are just the fundamentals. You can also get higher harmonics. For example, for closed, closed, you could have this kind of shape. Or for open, open, you could have this kind of shape. Or ones with more wiggles in until you get the right combination of nodes or antinodes at the ends. So there's a whole set of higher harmonics that apply to any particular situation, open, closed, 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 or open, open. And if both ends are open or both ends are closed, then the length is related to the wavelength in the following way, where n is 1, 2, 3, and so forth. And if you have this case where you have one open and one closed, then that lowest one is lambda on 4. The length is lambda on 4. Then the next one, you're going to have an extra half wavelength, so that'll be 3 lambda on 4, 5 lambda on 4, and so forth. And so a formula that gets all of that is, again, for n being 1, 2, 3, and so forth.